type of systems, right? So now the operation systems can be different, right? There are every company is using different type of systems. So maybe as a part of your own notes, maybe you want to note down what are the different type of systems your company are using for different purposes. So it can be your CRM. What are you using? Is it a cloud based? Is a document based? Is it a production? Because that will be one of our assignment in the future. So you it's better for you to collect the, because I would be asking you to create a business the data warehouse structure, that overview that I show you earlier, where we will be mapping out how we are doing the system or what you would like to do. So you may need to want to understand what kind of systems are we using. How are we doing the CRM? Is a cloud-based system? Is a property-based system? Or is just an Excel sheet? What are they? Are we using any system for production? Is it different from inventory? Is it different from finance? Is it different from sales? Is it different from billing? What else system are we using? So their companies may be using different type of systems for different type of purposes, but most commonly there are separate systems for CRM, mostly the customer relationship and billing. There are separate system for accounting and finance, and there are usually systems for production control in the factories, in the production, and there are separate systems for supply chain management, i.e. logistics, purchasing and store management and warehouse management. So these are the three or four basic categories of systems that the companies may be using, and they use it for it can be standalone or it can be interface. So the difference between standalone and interface is usually if the system is not interacting with the another system in any way. So that is called standalone system. But usually there are like APIs. There are advanced programming applications which are created by for integrations, which is created by the programmers from to integrate different systems. So maybe the input or output of the CRM can be the input for finance. So there may be a process whereby they are able to integrate. For example, in hotels, I give you the example of hotels. We have website where we have a booking engine, where you are booking. So that booking is normally interfaced together with our property management system, which is separate, which is different. It's a standalone system. They are never integrated with the booking engines, right? I mean, they are not same as the booking engines. So there is an integration happening between the two systems by way of API. So they connect. There is a server, separate server, where the data is stored by one application and it's taken by the another application on a daily basis. So it can happen on a real-time basis, means the data is continue to upgrade and synchronize within like every 5 minutes, every 10 minutes, or every day. That is called the batch processing. If it happens instantly, means you collect a booking now and in the next second it will be reflected on the PMS. It's a real-time situation. That happens like the exchange rate systems with the bank, where the bank is updating the in the back end. They update the rates, and everywhere around the country, around all the branches, the rate is reflected immediately, right, for money control. So that is called real-time systems. So normally we have a property management system, then we have a finance system, which is separate. Sometimes it's a separate system. Sometimes it's part of one ERP, which is creating the input for the finance entries, accounting entries for revenue accounting or for purchase accounting, which is sometimes is linked, sometimes it's not linked. Sometimes there is a export file into CSV and then you import into the finance, or sometimes there is a API again where they save the data to a certain location, and finance system is taking the same data from to input into their own. So basically this API means you are transforming the data from one system to another system by to agree on a common format. Otherwise the data will not be matching, right? They will not be able to integrate. So these different systems can be mapped and can be non-mapped. So you have to identify that what are being mapped and what are being non-mapped. So you may want to have a structure of your own systems in your mind. So basically, whenever you are using the as a good practice, what the companies need to make sure is that their data is same, right? Their data is the naming conventions is same, properties are consistent around the systems. If you are buying the system from the same vendor, it's easy to do. But if you are buying the system from different vendors, it's pretty difficult, right? And if especially when they are ready-made softwares. So in that case, the data naming convention, the properties may not be the same. So to overcome that, you need special systems which are extracting the data from each of the separate systems, and you will be compiling into the you will be inputting into your data warehouse after you transform the data into one standard format, right? So that is there's another system called master data management system, which is usually developed to connect the data around different systems. So there may be a master data which says the customer name is A. It's called A dot one in CRM, is called A in finance, is called A dot two in inventory management software. So that this master data will tell how the different data fields are connected. If they are in different currencies, then the master data will convert them into one singular currency using a standard rate, which the users have to provide, and then combine into one database. So there has to be one master data management system as well. If the company is using different type of operating systems which needs to be connected, and to help this, there is usually a technology called ETL, extract, transform, and loading technologies, which helps to manage the data in the warehouse, and which is we have discussed in our previous overview. The ETL technologies are the bridge between your different operating systems and your data warehouse. So they take the data from operating system, match with the master data management system, and transform into one same format, same singular, same definitions, and put into the data warehouse. So that is the overview of your different operating systems. Is it clear? Operating systems?
Yes.
Okay, so you don't have to tell me now, but you may want to list out the systems that you or your company, I mean your company is using, and for what purpose, and how, if they are integrated or they're not integrated. So you may want to just put them into a simple Excel form, and then how they are getting the data is the input from one system is used as another out is the output of one system is used as input of one another system or not, or how they are integrated, if they are integrated, how they are integrated. So you may want to just make a master sheet that will be used in our assignment later on. Okay, now the data warehouse subsets, as we have discussed in our overview, we discuss about the data mart. So data mart basically, as I explained earlier, is they combine the data across the entire enterprise and segregate into use base. So the data process, because if let's say the data warehouse combine the data all across all the enterprise, and once you are analyzing this data into the whole data, it will take a lot of time, right? You are making a pivot table with 100 rows, or you are making a pivot table with 10,000 rows. It's different. The processing time will take different, the file size become different, and the speed at which you will be able to generate the results is also different. So what data mart does is they consolidate only the relevant data into the smaller chunks, so that the processing is faster and the results are also quicker. So they are smaller clusters focusing on specific subject or department, and combining the relevant data from the entire data warehouse to make the processing much faster and easier. And also it protect the data integrity and data confidentiality, by showing only the relevant information to the relevant user, and it avoid definitely the confusion and also the overload of data. So that is the job of data marts. Then there are usually operational data stores or ODS. They are dynamically updated information involving the critical information, involving the critical areas. So you may be identify the critical information you may want to use more often. For example, the daily sales. For example, the cash balance. For example, the number of customers. For example, the queue of customers in different organizations, right? So these are very specific thing which the users are being using it on a daily basis, on a every minute basis. So usually these are you can say it is just like a short-term memory, like a RAM, which in your computer you have random accessible memory, which is keeping the information which the computer is using, calling all the time, right? So that part keep the information which is always useful for everybody, and then it's dynamically updated so that it's relevant all the time. And then the third subset of the data warehouse is the analytics, or called visual applications. So that visual application is normally the front end part of the warehouse, which is responsible for interacting with the users. So users are not directly interacting with the data marts or with the data warehouse. They interact with the another dashboard, or like called front end, like for example website, right? When you are accessing the website, you are accessing with the front end, but there is a programming at the back end. There is a data warehouse, there is a database which you don't see, but you are interacting with them through the front end. So that's the analytics part, and the visualization applications are, you can call them as a front end part of your data warehouse, which is responsible for the interaction with the users, right? For example, your charts, for example, your structures, for example, your reports. So those are the front end, and entry also is sometimes usually done from the front end. So there is front end has two parts, one for inputs and one for output generation. So if any software, you will see there is one data entry and one is the report section. So these are the two front end parts of the database, one to enter the data and one to extract the data. Okay, now let us try to understand the different type of architecture in the data warehouse. So that architecture means how is it built, how many tiers it has. So when we say we call it n tier architecture. So n tier architecture means how many tiers, how many tiers or how many layers are there between the user and the actual database, right? So this is called the three-tier database structure, where you have the information source, which is semi-structured source or the structured source, and we have operational database with extract and put into the data warehouse, which is called tier one. Then you have OLAP servers, which are usually responsible for processing it. That is called a tier 2 database, tier 2 servers. And then there are normally the client database, right? The client means the query, the reporting, maybe a dashboard, or another application which users are using. So users are not working directly on tier 2, they are working on tier 3, the actual users on client systems. So that is called the n tier architecture. So what are the different interaction between the user to the actual database is defined by the n tier. So if let's say the users are directly working on the data warehouse, it will be called one tier system. If they don't have a separate OLAP server, means the server sits on the data warehouse, but they just only have the clients which is directly linked to the data warehouse, then it will be called two-tier system. At this point of time, it's called three-tier system because there is a data warehouse, there is a separate processing server, there is another client server. So to give you an example, in our hotels, usually the maybe no one will be understanding it because he has an experience with the Opera system, where it's a three-tier system. They have a separate data warehouse. they have a separate processing server, and then they have a separate server for the clients, which is on the PCs. So the clients are always on the individual PC of the users. Then there are servers. Servers are usually, there are processing servers, because if the database is very big, you need separate processing power. You cannot run the database and its processing on the same server, because it becomes slower if the database size is huge. But if database size is small, for example, let's say a Excel spreadsheet, the access, the server and the processing can be on one tier, means direct. So it's called one tier. But it happens only with the small organizations, not with the large organizations. So that is the three-tier system. Or there are some that is called web-based data warehouse, which is means that the application is based on web server, right? So for example, web pages. So there is a web server which is taking the processing from another, like the nowadays with the cloud with the cloud-based systems on your architecture. So behind the cloud, right, behind the application which with the web page which you are accessing, which is you are as a user, which is you are interacting with a web server. That web server has a web page for everything: login, reports, and entry and report extraction on everything. But behind that, they have a separate another two servers, which is called application server and also data warehouse. So, and this web server is interacting with the both, with the application server and the data warehouse. So data it takes from the data warehouse, and it get it manipulated by the application server, and then it's sent to the web server, where the front end is coming in the form of web pages on a separate web. So this is called the web based transaction. So there are two main type of architecture. One is web based, one is the property based. So property based can be n tier, and cloud based is usually the web cloud based. There is not many tiers into the web based database. Any question about the data warehouse architecture?